Good morning to one and all. As a part of drawing ray diagrams, in this class we are going to draw ray diagrams for various positions. First of all, we are going to draw ray diagram if the object is placed between focal point and center of curvature. I already told you in the previous classes, this is the symbol of convex lens. This is the symbol of concave lens. This is C1, this is F1, this is optic center. The center of lens is treated as optic center, and this is F2, this is C2. Now the object is placed between focal point and center of curvature. When the object is placed between focal point and center of curvature, then I already told you, when you are drawing ray diagrams, 2 points to be kept in mind. One is, one ray should be drawn parallel to principal axis and another ray should be passing to optic center. The ray which is parallel to principal axis will be always passing to the focus. And the ray which is passing to the optic center is undeviated. So, the image is formed beyond center of curvature. The image is magnified image when compared to the object. What are the points that we can conclude is, image size is bigger than the object size, then the image is treated as a magnified image, then it is an inverted image. I already told you that very clearly, if the object is on one side and the image is on other side, then the image is treated as a real image. So, my dear students, please remember, when any object, if you want to find out the position of the image, when you are placing the object between center of curvature or beyond center of curvature or on the focus, whatever it is, you have to remember 2 points. One ray should be drawn parallel to the principal axis and another ray should be passing to the focus. Now, let us consider what happens if the object is placed at focal point. This is the principal axis, convex lens. This is C1, this is F1, this is F2, this is C2. Now the object is placed at focal point. When the object is placed at focal point, same rules. One should be drawn parallel to principal axis and another should be passing to optic center. The light ray which is parallel to principal axis will be passing to the focus. The light ray which is traveling to optic center is undeviated, and you can see very clearly in this figure the image is formed at infinity. In the previously, when the image is at infinity, when the object is at infinity, the image is formed at focus. That image is a point-sized image. Previously, we learned in previous classes. Now, if the object is placed at focus, when the object is placed at focus, then the image is formed at infinity. If the image is formed at infinity, we cannot say the nature of the image. On the same lines, we cannot say the size of the image. Nature of the image and size of the image cannot be predicted if the object is placed at focal point. And let us consider 2 more situations. Normally these ray diagrams are seem to be tough when we see on the book. But if you really understand the concept, these are one of the easiest topics. Now let us consider this situation if the object is placed between the focal point and optic center. This is the principal axis. This is C1, F1, optic center, F2, and this is C2. Now, the object is placed between focal point and optic center. If the object is placed between focal point and optic center, as usual, two rules should be followed. One should be drawn parallel to the principal axis and another should be passing to optic center. We already know that if it is drawn parallel to principal axis, will be passing to the focus, and the light ray which is traveling to the optic center is undeviated. Now where is the image formed? If we extend these two rays, the image will be formed here, and the image which is formed is a magnified image, and the image which is formed is a erect image. The image which is formed is a virtual image because the object is one side and the image is also on the same side. I told you in many classes, if object is one side and the image is also on the same side, then the virtual image is formed, and similarly virtual image is formed and it is erect image. For the first time we are listening erect image in this class. And now this kind of principle is used in building microscope. Some of the things cannot be seen with our naked eye, can be seen with the help of microscope. If the object is placed less than the distance of focal length, then we will be getting magnified image. That is the principle involved in the construction of microscope. Sometimes in the examinations they will be asking you, appreciate the role of convex lens, and you can clearly write that if the object is placed between focal point and optic center, if we are looking from the convex lens, then definitely the image is a magnified image. That principle is used in microscope. Normally everybody know the importance of microscope. Some of the things which cannot be seen with our naked eye can be seen with the help of microscope, which can magnify up to 10,000 times. Now let us consider in the case of concave lens. Up to now we have studied about convex lens. Now let us consider about concave lens. Concave lens is represented like this, and this is the principal axis. Previously for convex lens we started writing like C1 F1, but for concave lens we have to write C2 F2 F1 C1. Now initially let us consider the object is placed between center of curvature and focus. Same rules. One ray should be parallel to principal axis and another ray should be passing to the optic center. The ray which is passing to the optic center is undeviated. The ray which is passing to the optic center is undeviated, and when the light ray is traveling from denser medium to rarer medium, the light ray bends away from the normal, and similarly in the case of this, it bends away from the normal. It bends away from the normal. And if we extend this, the image will be formed here. If we extend this, the image will be formed here. The image which is formed here, the image exactly formed here, the image which is formed here is a erect image. It is a virtual image formed on the same side, and it is a diminished image. Thank you.